Right when the researchers at NASA organized and developed the James Webb Space Telescope, they trusted that it would manage how we could translate the universe and help us with researching the fogginess of space. However, to their surprise, this super telescope, intended to uncover what many had dreaded for years, identified a bewildering cosmic phenomenon just minutes after its launch. The discovery of this anomaly could have catapulted the James Webb Telescope into extraordinary status. At any rate, it has sent the cosmology world into a wide-open debate. What is the X7 object? Why is it headed toward a black hole? Could black holes serve as gateways to incomprehensible realms of knowledge? One of the essential aspects of the universe is that it has been a mysterious expanse for a long time. People have been spellbound by, and excited about, the secrets of the universe, eager to unveil the insider realities it holds. This curiosity has driven us to imagine breakthroughs that are testaments to our technological advancement and scientific achievements. One such breakthrough in space research is the James Webb Space Telescope, the latest in a long line of space telescopes and observatories. The Hubble Space Telescope, launched in 1990, was one of its predecessors and remains one of the most renowned and influential telescopes. It helped us understand various aspects of the universe, including its expansion rate. Another significant telescope is the Spitzer Space Telescope, launched in 2003, which was valuable for observing cool objects like distant galaxies and focusing on star formation. The Kepler Space Telescope, launched in 2009, aimed to discover exoplanets and investigate the smooth pathways of the cosmos. Then there's the Fermi Gamma Ray Space Telescope, which focused on high-energy phenomena in space. The James Webb stands apart from all these telescopes. Its journey began with a solid vision to expand the limits of space research and enhance our understanding of the universe. It was conceived as the successor to the famous Hubble Space Telescope, drawing inspiration from the successes and challenges of past missions. The JWST was designed to overcome the limitations of its predecessors and pave the way for groundbreaking discoveries in space science and cosmology. After a remarkably long period of careful planning and development, it was finally ready for launch in December 2021. The James Webb Telescope embarked on its mission aboard an Ariane 5 rocket. Unlike its ancestor, the telescope was optimized to observe the universe in infrared light, enabling it to look through dense clouds of gas and dust and capture images of celestial objects that might have been hidden from other telescopes. One of its primary goals was to study the formation and evolution of galaxies, providing insight into the events that propelled the early universe into existence. By observing distant objects in the early universe, the telescope offers valuable data on the formation of stars and planetary systems. The James Webb Telescope is also equipped with advanced instruments to study exoplanets, which are planets that orbit stars outside our solar system. By examining the conditions of these distant worlds, researchers hope to uncover clues about their composition, atmosphere, and potential habitability, laying the groundwork for future investigations of distant planets. Perhaps one of the most significant capabilities of the JWST is its ability to capture images of distant objects in the early universe with unprecedented clarity. With its high-resolution instruments, including the near-infrared camera and the mid-infrared instrument, the telescope can detect faint signals from distant objects billions of light-years away. This allows cosmologists to explore the universe's structure, from the first galaxies formed after the Big Bang to the remnants of ancient cosmic events. Clearly, the most exciting aspect of the James Webb's advancements is its capacity to observe the formation of stars and planetary systems in great detail. The telescope can collect more light than its predecessors, enabling it to see the faint emissions of young stars hidden within dense clouds of gas and dust. By focusing on these stellar nurseries, researchers can gain insights into the processes that lead to star formation, from the collapse of molecular clouds to the creation of protoplanetary disks and the formation of planetary systems. These types of discoveries have not only expanded our understanding of the universe but have also paved the way for future revelations. The telescope carries the promise of unveiling new snippets of information about dark matter, the dynamics of galaxy formation, and the search for potentially habitable planets. NASA's administrator, Bill Nelson, remarked that the James Webb Space Telescope is indeed a remarkable achievement in exploration. With the telescope's ability to investigate ancient galaxies and examine the universe, we can now glimpse the formation of structures that existed a few 100 million years after the Big Bang. This was considered to be an extraordinary accomplishment. Understanding these ancient relics challenges our previous conceptions of cosmic evolution, and there are now indications that the universe harbored more complex structures earlier than we had imagined. This revelation has ignited numerous new research questions, prompting scientists to reconsider the mechanisms driving cosmic growth. Researchers have also been compelled to investigate the role of dark matter in shaping the universe's large-scale structure. Dark matter is regarded as the invisible force that quietly influences the intricate motions of galaxies. Astronomers have been fascinated by this enigmatic substance for a long time. Gaining a clearer understanding of its properties holds the key to unlocking some of the universe's most profound secrets. The effects of dark matter are significant and far-reaching. Its gravitational influence acts as a crucial framework that shapes the development of visible structures, leading us to explore the very fabric of our reality. The discovery of dark matter was the result of many years of meticulous observations and advanced technological developments. We have come to understand that galaxies behave in ways that challenge our conventional understanding of gravitational dynamics. Their movements and distributions suggest the presence of an unseen mass that affects the visible matter we can observe. The implications of dark matter's existence are vast, reshaping our understanding of the cosmos and prompting further exploration of the fundamental forces that govern it. IMMSE augmentation plan of the universe. Furthermore, it's more to organize the arrangement of structures for the most part through the universe. Dark matter could hold the way to deal with relaxing the special experiences, including the improvement of the central stars and systems in the early universe. It is acknowledged that these beginning-stage divine bodies rose out of the gravitational seeds planted by the variety of weak matter density. Intense examinations and forefront molecule gas pedals have been normal to recognize and zero in on the fascinating particles that could incorporate dark matter. Complex reenactments and hypothetical models are additionally set up to uncover understanding into its properties. Besides, ways to deal with acting seeing that is essential. The mission for dark matter isn't simply a smart endeavor, in any case, it holds critical ramifications. Hence, the James Webb Telescope has given shocking snippets of data into the clandestine universe of dark matter and extremely colossal dark openings by taking into account the gravitational lensing impacts given overwhelmingly off dark openings. The telescope has uncovered that there were really colossal dark openings in the early universe, far sooner than anyone had anticipated. With this data, the reasonable world is mumbling with demands as to the beginning stages of these impacted Goliaths and their occupation in the progress of universes. We in addition learn about the collaboration that drives the development and movement of very enormous faint openings. This has offered new roads for assessment concerning the chance of these enormous advantaged bits of knowledge. Dark openings are these confusing parts with masses millions and billions of times that of our Sun. They apply a gravitational beat serious areas of strength for so not even light can move away from their hold. While different hypotheses propose that these grandiose Goliaths formed from the breakdown of colossal gas clouds CLS in the early universe, the James Webb Telescope is on a trip to reveal their authentic early phases. Another widely inclusive hypothesis proposes that dark opening construction arises from amazing thickness changes of the young universe that step by step accumulate mass through gathering these bodies. Likewise, converged with other dark openings to form into, finally, monster openings, as shown by observations made by the James Webb Telescope. This hypothesis could have a reality to it. The observations uncovered the presence of incredibly gigantic dark openings returning 200 or 300 million years later. The massive impact of this is a gigantic change in the way we might unravel dark opening headway. It likewise proposes that faint openings hope to be an essential part in the early movement of universes. In like manner, the JWST has revealed the Durs exchange between really gigantic faint openings and the universes that have them. When matter from moment stars and gas gravitates toward the gravitational reach of an exceptionally enormous faint opening, it undergoes a cycle thought about improvement. This plans a rotating circle of hot gas and development meant as an advancement plate. As issue falls into the faint opening, it discharges huge extensive energy as radiation and strong planes of particles. These planes of particles shape the general anal climate and basically impact the progression of the universe. The impact of exceptionally immense faint openings connects past their nearby district and can influence the improvement of stars and the progress of universes on infinite scales. It is similarly important that the limit radiation and blasting spills over conveyed by these self-important monsters can warm the gas inside universes. When these gases are warmed up, the headway of new stars is repressed, which can change the general arrangement of the structure. These floods can in addition set off the headway of stars in different neighborhood individuals of the structure. This intends that there is a solid trade of dark openings and splendid births, passing dark openings in weak matter. The James Webb Telescope has changed how we may unravel star plan and the show of planetary frameworks by getting pictures of brilliant nurseries and protostellar circles. The telescope has given remarkable snippets of data into the cycle that direct the course of action of stars and planets at the place of combination of how we could interpret the universe. Our reality began with the colossal impact. This hypothesis is the central system that opens the different arrangement of our universe's progress. As shown by this hypothesis, there was a particular spot of enormous thickness and energy where the surface of space and time was considered around 13.8 billion years ago. The solitary occasion demonstrated the start of our universe to the degree that we might be concerned in a little piece of a second. This starting stage fireball loosened up at a dazzling rate, making a way for the fantastic orchestra that proceeds to fan out straight up to the current day. Experts imparted that as the universe co-cooled and expanded, the fundamental disarray gave way to referencing other than the head subatomic particles that arose, planning the development blocks of issue. These particles, confined by the urgent powers of nature, coalesced into superatomic focuses, and finally, the essential particles worked out true to form. Their fragile dance, tended to by the laws of quantum mechanics, made a beeline for the improvement of stars and universes that would later understand human progress. Experts went as the years progressed, finding and empowering this arrangement until the James Webb's telescope came to change things with significant divulgences. The divulgence that faint openings and structures were in the accounts of the universe has attempted the supporting of cosmological speculations. The JWST observations feel an insignificant dubious on this quick story, revealing endless substances that appear to go against the standard timetable. These starting stage self-absorbed behemoths tested the possibility that structures formed bit by bit over billions of years, proposing rather that universes were at present in existence not long after the primary involvement in the world. This disparity raises basic issues about the course of events of enormous development and the parts driving universe strategy. Additionally, as shown by the standard strategy for thinking, incredibly monster faint opening structure through the drowsy conglomeration of issue throughout perpetual time scales. However, the presence of fluctuate enormous faint openings by later the enormous blast, recommends an even more fast and confusing course of faint opening headway, testing how we might translate the gigantic sails. These disclosures have sent shock waves through norm experts, inciting a reassessment of existing cosmological hypotheses. Trained professionals are grappling with the repercussions of these revelations, expecting to oblige the striking experiences with the spread-out structures of cosmology. One potential clarification for these odd exposures is the presence of elective models of infinite improvement. Several specialists have suggested that the universe went through times of fast turn of occasions and expansion known as enormous advancement. This plug would have set off the improvement of universes besides faint.